In this movie, I want us to start to understand file permissions, or more specifically, who has what permission to access, read, and write our files and directories. Now, permissions can be a very thorny issue, and they require a lot of tinkering to get things exactly right. It's a big enough subject that I actually recommend that you go off and research it further on your own, but I'll at least give you an introduction to get you started on the right path. Now, one of the reasons why we want to use file permissions is because of the security that they provide. They give an extra layer of security that ensures that people on the web cannot access files and folders that we don't want them to. And once we put our website into production, put it out for the public to use, we want to be constantly vigilant about exposing our website to hacking. One tip that I'll give you is that it's always a good idea, if you're going to have files be uploaded, that you upload them into their own special separate directory, separate from the rest of your code, because then we can make the permissions on that folder looser, and we can say you are allowed to write to this directory. But some of our other directories can be a little bit tighter in their security. We can say, no, you aren't allowed to write anything to these directories, and that way we can make sure that people don't change our files or modify our code. In general, you want to grant as few permissions as it takes to get the job done. Now that's once we're in production, once we've launched it to the public. For now, we're in development. We're on our own machine and we don't need to worry about hacking. So we can have our permissions be wide open. But it's still going to be important for us to understand file permissions to make sure that we're allowed to do the things that we want to be able to do on our development machine, that permissions don't get in our way. And that's what we'll be looking at now. Now, most of the way PHP is going to handle permissions is going to be the way that Unix handles them. So I need to say a word first about Windows and how Windows file permissions works. It's a little bit easier and it's a little bit harder. The reason it's easier is because it's going to simply manage through the Properties Security tab. So you'll go to Properties for a file, click on the Security tab, and then you can manage the permissions for that file. If you can't see the Security tab, you may need to enable that feature first. Now, the default permissions that Windows has may work. In general, it tends to be wide open, and so you probably won't run into any problems. The other reason it's easier is because the security model for Windows is much simpler. You basically are a user who either has access or doesn't have access. Now, it's a little bit harder, though, because different versions of Windows handle it slightly differently, and the way that the properties and the security tab work are a little bit different. And this chapter will also present a little bit of a problem for you if you're a Windows user, because many of the PHP methods that we're going to be talking about are either going to be fully ignored or partially ignored. So Windows users, default permissions may work, and you may not need this chapter at all. But I think it is still useful for you to understand in case you deploy to a different environment later. PHP, remember, is not platform specific. So now let's talk about the way that Mac OS X, Unix, and Linux do their file permissions, because they're all done the same way. Basically, we have three categories of users that could be coming to our file. We have user, which is us, the person who created the file, the owner of the file. There's group, which is a group of users, and we can assign people to groups. And then there's other, which is everybody, the public at large. So it's not us, it's not someone in one of our trusted groups, it's just other. And we have three types of actions that we can do to a file or even to a folder, and that is to read it, to write to it, or execute it. And in the case of folders or directories, execute actually means list the contents of what's in the directory. But since we're mostly interested in files, we're talking about being able to run executable files. So let's suppose that we have an imaginary file, and we want to grant permissions to user, group, and other that look something like this. We want our user to be able to read, write, and execute a file. Group can read and write it, but not execute it, and other can read it, but not write it. This is just a real simple example meant to show you how we can have different permissions for the different categories. You'll notice that I have those abbreviations, R, W, and X, next to read, write, and execute. That's because those are the abbreviations we use when we summarize these listings. So for user, if we can both read, write, and execute, it gets R, W, and X. And group, you'll see it gets R and W, and then just a minus sign in place of the execute. Other is the same thing, but with only the R and then two dashes. We call this symbolic notation, and you'll see it from the command line inside Unix, Linux, or Mac OS X. Usually they're all run together, and they're in that same order, user, group, and other. Now, there's another kind of notation that you need to know about, which is called octal notation. Now, in order to get from octal notation to symbolic notation, you're going to need to do a conversion. And the key for conversion is what I've got there. R equals 4, W equals 2, X equals 1, and the dash equals 0. So then, with that key in mind, we can take RWX and convert it to 7. And RW would just be R plus W, So that would be 4 plus 2, 6. And R by itself would be 4. Now we have a shorthand for being able to talk about that whole string of letters up at the top. And that's called octal notation. So 7, 6, and 4 represents the exact same thing as the symbolic notation RWX, RW-R-. So 764 is a lot easier. Once you do a lot of these file permissions, you'll start to get familiar with them. 777 means let everyone have access. 000 means let no one have access. 666 means let everyone read and write it, but not execute it. So you start to get the idea. So before we move on to actually demonstrate this from the command line, I want to talk about one more concept, which is who am I? Now, that sounds very metaphysical. What I actually mean is, who is the web server? We saw from the file permissions that there's an owner of these files. So we have to know who the owner of the file is, and then know who the web server is to know whether the web server has access or not. Now, often you'll find that the answer to who am I is nobody. That sounds like a Zen answer, but in fact that is a valid user on a lot of Linux systems, is nobody. Sometimes though, instead it'll be www or Apache. And I'll show you a way that might help you to determine which one of these your web server is running as. So here I am at the command line, and I'm already navigated inside my B2B sandbox folder so that we can look at the files that are there. Now, the first thing I want to show you is that if we type ls, it'll give us a listing of all our files. If we type ls-la, it'll give us a listing of all our files with their permission information. So you'll see now in this list the symbolic notation that we were just talking about. So for example, in parent.php, we have read and write permission, but not execute for the owner of the file. And then we have the group set to be able to read it, and everyone can read it as well. Now we also can find out who the owner of that file is. That's given right here. That's the first column where it says Kevin. So I'm the owner of the file. Yours will obviously say something different. And the group information is the second column there. What group owns this file? What group has access to it? Now we're not going to be talking a lot about groups, but the concept is very simple. If we were to take users and put them into a group, we could then assign ownership of a file to a group, and then everyone who's in that group would have those access permissions. For now, we're just going to be working with user and focusing on the user having access. So we asked who am I earlier. My web server is most certainly not Kevin. Now it might be part of the staff group, but I don't think it is. So the question is, what access then does my web server have to parent.php? It's not the user, it's not the group, so it would be other. So in this case, it would have read access. If we wanted to modify those permissions, which we'll see how to do in a bit, then we would need to change it for other so that other would have different permissions. Now, I've told you that I would also give you a trick that might help you to identify which user Apache is running as. If we run the command psaux, that will give us information about the processes that are currently running. If we then put a space and the upright pipe, so that's just a straight up and down bar, space, grep, and then httpd, that will look for the web server process that's running. It will usually be called httpd. And if we do that, it will search for lines that contain that. And you'll see that we got a couple back. This is the important one here, which is that I have my web server running as www. You can ignore the underscore that's in front of it. What's important is that www. That is the user that my web server is running as. So now that we understand the fundamentals of users and permissions, in the next movie, let's look at how we can actually change the users and the permissions on a file.